In this lesson, we are going to cover the second part of special right triangles. So last lesson, we talked about the trig ratios, the special trig ratios for a 45, 45, 90 triangle. For this lesson, we are going to talk about a 30, 60, 90 triangle. And then we're going to solve problems involving those special right triangles by using those trig ratios that we've come up with. So now, remember from last semester, okay, in a 30, 60, 90 triangle, okay, the length of the hypotenuse is S. All right, so across from 90, we have S. All right, across from the 60, we have S times square root of 3 over 2. And then across from the 30, we have S over 2. All right, so those are the side lengths of our triangle. So when we want to find the sine, so we're going to start first with the 30-degree angle. Now remember with the 45, 45, 90 triangle, we only had to do it with one angle because all it had, other than the 90, all it has was 45. So we're actually going to find 6 different trig ratios today because we're going to do sine, cosine, and tangent of 30, and then we're going to do sine, cosine, and tangent of 60. Okay, so the first one that we're going to do is sine 30. Okay, so remember our nonsense word here, right? SOHCAHTOA. So sine is opposite over hypotenuse. All right, so if we're doing this angle right here, angle 30, okay, opposite is S, and then the hypotenuse is 2S. All right, if we look here, S over S cancels out, right? And we can't just, the 2 has to stay on the bottom, right? That there's a 1 there on top. So sine 30 is going to equal 1/2. Cosine 30, okay, cosine is adjacent over hypotenuse. All right, so here we have square root of 3 times S. Okay, that's the adjacent. And then we have the hypotenuse, which is 2S. So square root of 3 times S over 2S. All right, look, the S's cancel out, and we're left with square root of 3 over 2. And that's fine, because as long as we just don't want to end up with a square root on the bottom. Any type of radical on the bottom needs to be moved to the top. So tangent, we have opposite over adjacent. So tangent, okay, opposite is going to be S. And then adjacent is going to be square root of 3 over S. All right, so if we look here, the S's cancel out. So we're left with 1 over square root of 3. So in order to get rid of that square root of 3, we're going to multiply both sides, square root of 3 times over square root of 3. Square root of 3 times square root of 3 is just 3. It gets rid of the square root, and then we have square root of 3 on top. So tangent 30 is going to be square root of 3 over 3. Okay, and again, here we're going to do sine, cosine, and tangent of the 60-degree angle. So the sine for the 60-degree angle, we have opposite, square root of 3 over S, over the hypotenuse, which is 2S. So if we look here, the S's cancel out. So sine 60 is going to be square root of 3 over 2. Cosine 60 is going to be adjacent over hypotenuse. Okay, so adjacent to the 60 is S, and then the hypotenuse is 2S. So these cancel out. So cosine 60 is 1/2. Now, if you notice here, the sine and cosine were just switched, right? Cosine 30 was square root of 3 over 2. Now, sine 60 is square root of 3 over 2. If we look here, sine 30 was 1/2. Cosine 60 is now 1/2. And the reason that's true is because we just flip-flopped the two ratios, right? When we just took one side and then we switched the other side. So if you can remember that, sine and cosine, they just switch. And then tangent 60 is going to be opposite over adjacent. So that's square root of 3 times S. And then the adjacent is going to be S. So here S cancels out, right? We have that 1 on the bottom. So tangent 60 is just going to equal square root of 3. So here's a chart, okay, to help you remember this. If the angle measure is 30, sine is 1/2, cosine is square root of 3 over 2, tangent is square root of 3 over 3. If the angle measure is 60, sine is square root of 3 over 2, cosine is 1/2, and tangent is square root of 3. So here it says use the figure from problem 9, which here the figure is. It's this equilateral triangle EFG to write the specific trig ratios. Okay, so if it's an equilateral triangle, we know that all of these angles are 60 degrees, these big angles. Okay, so for this little angle then, so for this line, we know that this small angle is 30 because it divides it in half, and we know that this is 90. So this would be a 30, 60, 90 triangle. So for this one, okay, sine 30, all they're asking us to do is just write the ratios out. So all we have to do is just go back and look at our table. Okay, sine 30, if we have sine 30, it's 1/2. So if we're given sine 30, then we would have 1/2. If we're given cosine 30, okay, again, here's cosine and here's 30, so that's square root of 3 over 2. C, if we're given tangent 30, okay, here's tangent, here's 30, so it's square root of 3 over 3. Okay, sine 60, sine, and then there's 60, so it's square root of 3 over 2. Cosine 60, we have cosine 60, and it equals 1/2. And then we have tangent 60, our last one, tangent 60 is going to equal square root of 3. So that's how we can use that table. And so if we have to use any of these trig ratios, right, and we don't have our calculator, then we know that these are all that they equal. So you could just use this table right here to sub in for any of these measures rather than having to put that in your calculator. So here's our last, here's an example of how we can use this. It says Andrew wants to build a slide for his daughter's treehouse. If the treehouse is 5 feet off the ground and he wants the slide to have a 60-degree angle, how long of a sliding board does he need? Okay, so here's the slide. Right, here's the slide. All right, the slide is, or the treehouse is 5 feet off of the ground. He wants the slide to have a 60-degree angle, so that means that the angle is down here, right? It's from the bottom, okay, 60-degree angle. So how long of a sliding board does he need? So what we're wanting to do is figure out how long the hypotenuse is of this right triangle. So the first thing that we have to do is figure out which trig ratio we want to use, okay, or which trig sign, sine, cosine, or tangent. So if we look here, 60, okay, if we have 60 degrees, we have the opposite and we have the hypotenuse. So that means that we're going to use sine. So we have sine 60, and it's going to equal 5 over whatever the slide length is, which is going to be x. Okay, now let's go back here and look at what our sine 60 was. So if we look here, we're looking for sine 60. Sine 60 is square root of 3 over 2. So if we go back to our problem here, okay, so we have sine 60 is square root of 3 over 2. So we can sub in that for sine 60. And then we have 5 over x. So that's going to give us square root of 3 times x, because we're just cross multiplying here, equals 10. So then I can divide by square root of 3, and then I get x equals 10 over square root of 3. So now we're just going to find what square root of 3 is. And we're just going to say that it equals, we're going to round up and say that square root of 3 equals 1.7321. So now we're going to take 10 and we're going to divide it by 1.7321. And that's going to give us 5.77. So x equals 5.77. So that's the distance. That's about how long, if he wants his slide to have a 60-degree angle, then the slide length needs to be 5.77 feet long. And that's the end of special right triangles part 2.